I understand this is the quiet period of the day, so I'm going to talk through the concept of prototyping. It's funny that Brian was talking about it as well, and prototyping is pretty standard in a lot of industries. We're an Irish company. We do prototyping of industrial control and MEM systems. So I'm just going to talk a little bit about prototyping, what it is, the industrial control environment, and the benefits that one might get from prototyping. So we're going to start with a question. Why are we using prototyping in industrial control? Carpenters have an old adage called measure twice, cut once. So that what you do is you draw out something like a plan, you draw out a product, you draw out something that you can physically touch and feel and interact with before you physically build what your final solution is going to be. There's absolutely no building that's been designed in the last 20 years that hasn't used CAD. Nobody builds websites anymore without doing prototyping. Nobody builds mobile apps anymore without using prototyping. And yet, in probably the most complex environment, what we do is we put it down on a piece of paper, we draw it out, as you would know from the ICT Forge, you draw it out on a piece of paper, you try to get across really complex concepts like time on a piece of paper. You then go and build it, you then program up the final system, you then test it, then you hand it off and the guy goes, that's not what I wanted at all. So that is why prototyping is important. Let's talk a little bit about the landscape. Again, Dennis, this is not unusual to you. 4 layers, Purdue model, top layer being the ERP system, second layer down being the warehouse management systems type area, or the MES systems, third layer down scout patch. No great surprise. Bottom line is that in each of those layers there's lots of different systems. So it's an incredibly complex environment. And those systems often are from different suppliers, and so they require a huge amount of integration to get them to work. Because they are system specific, there's some human resource constraints. I'll come back to that at a later stage. But what it does mean that often in a manufacturing environment, and probably in other environments as well, but certainly in a manufacturing environment, there's lots of different silos of information. So for lots of people who've been talking about lots of big data projects today, and the difficulty is that the information is held all over the organization, some of it in spreadsheets, some of it in different formats. And then there are some new realities in manufacturing. Again, people were talking about IoT, I call it IoT, so Industry 4.0, data analytics, the IT-OT convergence. The OT, the operational technology guys who live in this world have effectively lost the battle to the IT guys. So the IT guys with their new concepts on data analytics and that are effectively overruling the old-fashioned guys. So those people were talking about earlier about air gaps between systems. These guys are pushing very hard to get rid of those air gaps. So that's the landscape. So we now know that, so prototyping is a pretty standard concept in lots of industries. We know that it's a really, really complex industry that we're in. So if we were going to bring prototyping into this industry, what would it look like? Well, again, prototyping is meant to be this easy to use, friendly, touchy-feely, visual, I understand what it is, or at least I'm not sure what I want, but I know it's not that. It's that type of a concept. So it's got to be easy to use. Pretty standard stuff. I mean, ultimately, you're talking about guys from quality are going to be sitting there the same as guys, process engineers, same as IT guys, same as various people, financial people, of which I am one, unfortunately. So these could be people from all over the organization, and if you really, really make it difficult, they're just not going to care. Short learning curve. Industrial control systems are not easy. These are difficult things. Running a manufacturing plant using a batch control system is not simple. But so especially when you've made it proprietary. So if you go to a Siemens system and you want to learn how it runs, you've got to speak Siemens. And that's nonsense, because ultimately the process is 80% or 90% of how it should work, and the proprietary side is only 10%. It's got to be accessible, so you can't have guys unable to get into the training room or whatever that is where the systems are. It's got to be visual. This is Google Blockly. Google Blockly is what they use for visual programming for children, and we're just sort of giving you a quick feel of what it might look like in an industrial environment. So set valve to open. Pretty simple stuff, but anybody can understand that. It's got to be quick. Again, it is a prototype. It's not meant to be the final solution. It is then meant to be a prototype, so it's meant to be within an hour I can turn around and get across some concepts to you. I've talked about collaboration here. It has to be a collaborative thing, because as I said, what tends to happen in an environment in industrial control is you make it, you hand it over, and guy goes, that's not what I want. So what you want to do is get that collaboration earlier on. Standards, I use the word standards here, it's terribly important because a lot of organizations, like for example the International Society of Automation, like for example the OPC Foundation, they've already done a lot of the hard work. They've already decided how these plants should operate and should look. So what you do is you just take them and you incorporate them in. And then fidelity. Fidelity is a really interesting thing when it comes to prototyping, because often, especially with stuff like websites, the prototype becomes the final version. The great advantage here is that because you're going to buy a formal system to run your plant, the model is never going to turn into that final solution. Secondly, as well, in relation to fidelity, some people only want to see the very, very high level, some people want to go into the detail, and you need a solution that can cover both. So we now know what it would look like. So what are the benefits? Again, this is pretty standard stuff for anything to do with prototyping. Why does anybody prototype? Well, the design phase is faster. In this case, digital design phase. So rather than, and Dennis, you may forgive me, was that done on Visio, those diagrams? The diagrams that you showed earlier on in relation to the process?
It was an open source, platform.
Okay, so exactly. So it's one of these ones where you sit there and you've got to learn a little bit about the open source platform. Yeah. Exactly. So what we're saying is that use those digital concepts to also reflect how time works. And better collaboration. The whole concept of being able to turn around, sit around a room and go, bang, 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 that's not what I want it to work this way instead, rather than a single process engineer writing it down and then trying to transfer that knowledge to an automation guy at a later stage. So, in relation to the project time, obviously it's a little bit faster using the digital side, but also, if you're doing a project and you've decided that you may want to bring in an MES system, for argument's sake, you have an existing plant, you want to bring in an MES system, but you don't know exactly how that's going to work. So, currently what you do is you go and engage in consultants, and they turn around and they tell you what the best provider is, and then you engage that provider, and then you figure out how much it's going to cost you, and it often costs you 3 times as much as you hoped. What you'd like to do is actually kick the ball around a little. So turn around, try and figure out what you want, because ultimately it is a process. So what you really want to do is you want to figure out what information, when do I need it, what's it going to look like, where's it going to come from, and where's it going to go to. And so you do that yourselves internally by using this easy-to-use tool, and that means you can either yes or no decision, if possible, or alternative, if you are going to engage, at least you have documentation to hand to somebody because you now know what the process should be. And then the uses of standards, again, even quicker again. If you've decided, if you're Pfizer, for example, and you have 74 global plants, and in those plants you have chromatography in 5 or 6 times, that's 480 or whatever it is, times you've done chromatography, you know how to do chromatography. So the next time you build a plant, why do you do it from scratch again and pay consultants to do that? You just pull down the model, this is how we do chromatography, and you tell me why it's changed. That's how you do that. Okay, so that's the effect on project time. So in terms of project risk then, again, the collaborative concept is that if you sit around a room and you get your operations guy, and you get your quality guy, and you get your process engineer, and you get your automation engineer earlier on in a phase, they will be able to pull out errors much quicker than you are. So the operations guy who's engaged that early, he will turn around and say, that's not going to work for me, that's just not realistic. So that's why you use the program. Automatic documentation generation. So again, part of the process today is that when you design a process in relation to, say, an MES, what happens is somebody decides to define what it should look like. He then tries to type that up in a document. Dennis, you know this. Trying to type up a document, and then he hands that document to somebody who then has to try and interpret it. And so the automatic documentation generation is if you know what your process is, and it's a simple that, then that, then that, then if, then, when, why, what, all the usual stuff. And if you've got a visual model of what you know to be right, and everybody's kind of comfortable with that, well then the whole concept would be press your button and the documentation will pop out. You hand that to your automation engineer and you say, this is what I want the system to do. You also have the documentation, you also have the working model. Now, the only issue with that, of course, is that, I say no errors. If your process is wrong at the start, you're going to have a problem, because your documentation will reflect that. But there's no subjectivity, there's no simple spelling mistakes, there's no problem in translation. You also have a better cost and time estimation. So now you know exactly what the process, you now know how long it's going to take you to program up all these systems, so you get a better feel for the project plan. And more focused testing. It's sort of interesting in the pharmaceutical world right now, is that they're looking for risk-based testing, and if you ask a quality guy after a few pints, he will tell you that they often don't really understand how the processes work because they're couched in very, very difficult language, automation speak, that type of stuff. So whereas if you use a visual tool that has the level of degree that he or she needs, they can point out very, very quickly and say, that's going to be a problem for me, we're going to need more data there. Okay. So that's the affecting budget risk. And then the cost. So time and risk, we've talked about, and that obviously generates cost savings, so there's no issue there. But there's also some savings in cost in terms of resources. So I mentioned earlier on that there was some HR constraints, and I'm using the term quite broadly. Nobody goes into this industry because frankly it's not very sexy. So the average, there's more industrial control engineers over the age of 60 than there are under the age of 40. That's a fact. You can go, when you come out of college, you can either go into mobile, which is kind of sexy, you can go into Google, which is sexy, or you can go into the world of Siemens PLC program, which is not sexy. So there's a problem coming up in terms of going out the other side. Guys are retiring. We were at Hanover Messe last year. We had a booth in the Smart Factory. We had a gentleman come over who was 74 and told me he was the youth policy in the nuclear industry because he had an 84-year-old colleague who was paid $2,500 a day sterling because he was the only guy who needed a system manager. That's a huge issue. So this information needs to be captured. So this is back to the effect. Okay, so that's the project side of things. So we know there's advantages of doing the project. But there's other benefits as well. So operational excellence, again, we're back to the chromatography concept. You've got 500 different chromatographies essentially going around. And some of them are using Siemens, some of them are using Delta V, some of them are using Yokogawa. How do you compare them easily? You can't. It's difficult to do that. So one of the reasons for having a stand back and take a high-level view, high-fidelity view, you can figure out what's good, what's bad. You do 72 steps, you do 5 steps. Maybe I should take some benefits there. In relation to anything to do with operational excellence, certainly my own feeling is that modeling is certainly what you tend to want to do is you want to try and figure out what you've got today and what your ideal state is. And the concept of a prototype or a model to do that is far better than doing it today, which is playing around with live systems, which nobody wants. That's operational excellence. Knowledge management we've touched upon. Guys leaving it, guys walking out the door and stuff. Really interesting. Talked to a guy this morning. Gave him the 5-minute spiel, and he said to me, one of his clients has a huge problem in that they have been handed a control system, lock, stock, and barrel, which is kind of typical, Yokogawa system. But the problem is that the guys who maintain it don't know what's in it. So they have lots of documentation in relation to all the bits and pieces that go into it. But what they don't know is where those bits and pieces are, and so when something breaks, they've either got to ring the original consultants, which the system was put in 17 years ago, and so most of the guys are gone, or alternatively they've got to roll up their sleeves. And what he's saying is, well, why wouldn't you just put a straightforward, very, very quick physical model together of this is the various pumps and tanks that I've got, and then you can interrogate that. I thought it was a reasonable use case for us, but the other side then is, I've talked about the levers. The international standards, as I said, if somebody's already invented the wheel, why are you doing it? Just take what's there, thanks very much, take the ISA standards, take the OPC Foundation standards, take wherever standards are out there, ram them into your model. That's how the systems are going to work anyway, so you may as well use that as part of the prototyping. But then the corporate know-how, which is the clever stuff, the recipe management and stuff like that, that's the really clever internal stuff, and so you want to combine those. And then the other benefit that we see is training. So again, what I did say in relation to so you learn Siemens, for example. You know how to program Siemens PLC. Well, you know what PLC programming is about 80% PLC programming and 20% Siemens. And so what you want to do is you want to try and teach them the 80%, and then they can pretty much do any of the PLCs that are out there, rather than teaching them how to do Siemens PLCs, and then if they have to go somewhere else, they have to go off to another bloody training. So what you do is you turn around and you teach them the process rather than necessarily the language, the specific language. Second thing there is, look, everybody knows in relation to training, or the vast majority of people respond better to a I-see-I-do type concept, an interactive basis, rather than here's some slides. Put it this way, if I had my way, we have a little touch screen where I basically sucker you into it down as you come up, and I can show you how easy it is to draw the plan, and people engage with that a lot easier than when they do when you go, here's some slides. And then the last thing in relation to training, and it is not the students do not like this, assessment is terribly easy. So when you go on a 2-day training course, and which is lots of slides, that's one thing. You go on a training course now with this type of a concept, and then you say, right, now I want you to go and program up how the chromatography works. I'll come back in an hour, and it's really easy for me to grade. So that's basically all I wanted to talk about. So I don't know if you've got any questions. Fantastic. How easy was that? Thanks very much for your time.